Python has data types like floats, strings, integers, and all sorts of stuff, but it doesn't have fractions. And you might think, why can't you just use floats? But floats have precision errors. So I'll show you now. This code, it just simply takes a float and converts it to a fraction. So right now I'm putting in the float 1/3, so it's just 0.333. Well, it should be going on infinitely, but floats have precision errors. So let me run this and you'll see what I mean. The 24 here, it's not, floats don't accurately store numbers. They only store them up to a couple digits. So this isn't a accurate way of storing fractions for actual calculations. So I decided to make my own implementation of fractions. Yeah. So now that you know why it's useful, okay, I'll talk about it. First off, a basic function I made is GCD. It just takes the greatest common divisor of x and y using Euclid's algorithm. This is a little more complicated, but it just tells you like how many decimals a number has. So for example, 0.1 has 1 decimal digit, 0 has 0 decimal digits, 3 point this has 4 decimal digits, and so on. So those are just like basic functions that are useful. Now here's the actual fraction class. Um First off, I made a, actually no, let me go to init first. Init, it creates the fraction. So yeah, there's a numerator, there's a denominator. The default numerator is 0, default denominator is 1. Then what it does is, so basically what it does is, if either the numerator or the denominator entered is a float, then it finds how many decimal digits each of the numbers have, and then it multiplies them by a certain power of 10 so that the numerator and the denominator stored don't have any decimal digits, so they're like a cleaner fraction. So yeah, this is just the multiplication process. Okay, let me talk about simplify. It just like divides the greatest common factor out here. It's pretty obvious what it does. And here what it does is it prioritizes if both the numerator and denominator are negative, then it just makes both of them positive because that's generally more simplified. You don't randomly make stuff negative. Anyway, internal string. This is the internal function that converts a fraction to a string when printing it out, and this just like calls that function. Yeah, it literally just calls it to print. So if the denominator is 1, then it's not a fraction, so it just prints the numerator. If the numerator is 0, it just prints 0 because like 0/3 is not how you write it. You just write 0. And then there's actually two formats of printing. You can either print it as a mixed fraction, which would be something like 2 and 3/7, and a normal fraction, which would be 17/7. So they're just different formats. So mixed, you would find the whole part using some math and then print it out. If the whole part's 0, then it doesn't really matter if it's mixed or not. So it just prints the same thing as the code below would, basically. And the code below is if it's not mixed, it just prints out numerator divided by denominator. Because all the simplifications are already handled when operations are done. So it's not like on the spot. Yeah, so there's a separate mixed string function. And then, okay, first function, adding. So adding two fractions, it's a pretty simple formula. You just cross multiply, and then the simplification, since you're actually creating a new fraction object, it's simplification is already done for you in the init function here. So it's actually really short code. Subtracting is just self plus negative other. And I'll tell you about how I define this later. So actually I'll tell you now. I define negative here by just multiplying the numerator by -1. Anyway, next is multiplying fractions. So it's actually the easiest operator. Just numerator times other numerator, and then the the denominator is multiplied. True div. So it's just division. Python just calls it true div for some reason under the scene. So it's the original fraction times the other's reciprocal. That's how dividing works with fractions. And float is, it just returns the numerator divided by the denominator as a float. Reciprocal just switches the denominators and numerators, so it's simple. So yeah, it's some pretty complex, compact code, 70 lines, and it has pretty good functionality. So let me show you. So I can create a fraction, 3 over 7. I could create a fraction, 2 comma 9. And then like I can do some nice operations like fraction 1, 3 over 7 plus fraction 2 times 9, which just becomes 2 because it cancels out. And then I print this as a mixed string, so let me run this now. Yeah, it prints out as a mixed string. So this is useful for maybe like more mathy programs and such, if you need to store fractions accurately for computing large mathematical tasks. Because floats aren't always accurate, and you might not want to like rewrite all the fraction code every time you're defining a new fraction. So this object could come in handy. And yeah, let me just show some more operations. Um, yeah, so I can make a fraction. Yeah, it really doesn't. Oh yeah, let me show you this simplification. So 25 to, let's do this, 25 to 25 over 16, and then frac 2 equals fraction 8 over 45, frac 3 equals fraction 2 over 5. This simplification is really effective. So if we print this out, it just 1 because it all cancels out. So it's pretty cool how it like functionally just does the math behind the scenes and simplifies the numbers. And yeah, that's pretty much it for the video.